The question is calculate the reading on the voltmeter. If you want to calculate the reading on the voltmeter, this is positive, so the conventional current will move through. This will block, okay? And they are connected in pair. Like you have a 12-volt supply is there. See, this is a 12-volt supply. I want to drive the charges in this way. And there's another 3-volt supply. I want to drive the charges in other way. So as a result, two supplies are connected in opposite direction. So what will the resultant? So what will the resultant here? Like if I have two supplies, one is 12 volt, which want to drive the charges in this way. Another is a 3 volt, which want to drive the charges another way. So what will happen to the resultant voltage or a potential? So it will be 12 minus 3, which is equals to 9 volts. So we'll have a 9 volts here and we'll have a 9 volts here. Like the reading on the voltmeter as a 12 volt and 3 volt. So 12 from here, like 12 joules per second, joules per coulomb, and 3 joules per coulomb. So the difference will be there because the potential difference voltmeter record the potential difference. So it's a 12 here and 3 here. So the difference will be 12 minus 3, which is equals to 9 volts. So the reading on the voltmeter should be 9. Is it clear?
Yes, sir.
If it was connected other way around, if it was connected like a 3-volt supply is there and it was connected other way around, then we will add them. So if this was like example plus and minus and this was plus, so this now 12 plus 3, so that will make 15 volts. Because when two batteries want to transfer energy in the same direction, so what is the total? Like if this was 12 and this is 3, so this want to deliver energy in this way, other also same way. So the total energy when the charge will come out, it will be 15 volts, 15 joules per coulomb. But in this one, according to a question, one is positive and negative, and the terminals are connected other way around. So one want to transfer 3 joules per coulomb, another one want to transfer 12. So what is the resultant? Resultant will be 12 minus 3, which is equals to 9. Calculate the current in 4.2 ohm resistor. So we have the voltage here, which is 9 because they are connected in parallel. So the combined, like the voltmeter reading is 9. So this will also have, and even this will not have any current. Why this will not have a current? Because the charges will flow because of the 12 volt. So this will conduct and this will block. So this, the same voltage, 9 volts will be here. So we have the voltage and we have the resistance. So we can find the current, which is a ratio between voltage and resistance. So the voltage is 9 and the resistance is 4.2. So 9 divided by 4.2, that will give us the current which is passing through this resistor. Determine the current in 2.1. So what will the current in 2.1? The 2.1 is actually blocking the current. So we don't have to calculate, the current will be 0. Why 0? Because the diode blocked the charges from flowing. So if the diode block means there will be no current. So without calculation, I will just say 0 ampere. Then determine the reading on the ammeter. So an ammeter reads, because we already calculated the current here, which was 9 divided by 4.2. So it was 2.14 ampere was the current. So if 2.14 ampere is the current here, so same amount of the current will flow from this side. Because as you can see, when we have the 9 volts here, and when we calculated the current is a ratio between voltage and resistance. The voltage here is 9 and the resistance is 4.2. So 9 divided by 4.2, we got 2.14 ampere. So this 2.14 ampere is the current here. The same 2.14 ampere flow through this and return the circuit. because we consider this for voltmeter, they have a very high resistance. So we consider the voltmeter has a negligible current. And this current is being blocked here. So all the current which is flowing through this 4.2 ohm resistor, that is same as the current which is flowing through the ammeter. So the same answer 2.14 will be there, the reading on the ammeter. Is it clear, this one? Calculate the electrical power transfer. So you have the, for 1 point, so you can use P is equals to, you have the voltage and current, you can use this formula. P is equals to I square R. You have the current and resistance, you can use this formula. Or P is equals to V square over R. You can also, so any one of them. I know the voltage is 9 and I know the current is 2.14. So I'll multiply, I'll get the power. A sample of a gas is in a sealed container with a volume 170. So this is V1. Exert a pressure. So this is P1. The volume of a container decreased by, they did not say the final volume is 70. They say decrease by 70. So if they decrease by 70, it means what is the final volume? The final volume should be 100 because originally is 170 and it decreases by 70. So it will be 100. So we'll use a formula P1 V1 equals P2 V2. So first pressure multiplied by first volume. Second volume is 100 and we'll get, just substitute the values, you'll get the final answer. So this is P1, this is V1, this is V2, and we'll find P2. Figure shows an electrical circuit. The light intensity of the circuit is increased from dark to bright. So if it is become dark to bright, so what happened to resistance of light dependent resistor decreases. If the resistance decreases, the potential here will decrease. In comparison, here potential will be more. So what happened to the voltmeter reading? The voltmeter reading will also decrease. So state the effect on the resistance that will decrease and effect on the reading on the voltmeter. So what will happen? The resistance decreases, so less potential across the LDR, and LDR and voltmeter are in parallel. So if two components are connected in parallel, they will have the same voltage. So if the voltage here decreases, the voltage across the voltmeter will also decrease. So 3 marks are there. 1 mark for mentioning, like the combined resistance of the circuit will, if this is R1 and this is R2, so the combined resistance is R1 plus R2. Okay. R1 remains the constant, R2 is decreasing, so the combined resistance will decrease. When the combined resistance decreases, the voltage across R1 will have more voltage and R2 will have less resistance, so less voltage, and voltmeter is in parallel to the LDR, so less voltage or a potential across the voltmeter. What is meant by the boiling point? The boiling point is a temperature at which a liquid turns into a gas, a fixed. Then a mass of a 0.3. So we have the mass is poured into a copper initially at 11. So that is the starting temperature. After a few seconds, the temperature of a container in the water is 95. Calculate the energy transfer from the water. So how to work out? You have the formula E is equals to the specific heat of a water is already given to us. Okay. So energy transfer is equals to Cm delta T. Is equals to Cm delta T. So specific heat is how much? It is 4,200. What about the mass of the water? 0.3. And what about the temperature initially? Look, water at its boiling point. So water, what is the initial temperature? Water was there at 100 degrees centigrade, okay? And there was a copper cup, a copper can is there, or a copper container, which is at 11 degrees. We transfer a hot water. So when we transfer a hot water into this copper container, the temperature of the container, and like water temperature is 95, the container temperature is also 95. So what is the temperature change for the water? Originally it was at boiling point and now 95. So temperature change is 5. So 4,200 times 0.3 times 5. So that is equals to 6,300 joules. This is the energy which is given out by the water. So when the water will give out this energy, all of this energy is absorbed by the can. Like the water is losing energy, the hot water, and the copper container is taking that energy. The next is calculate the thermal capacity. Thermal capacity is removed from the syllabus. Only specific heat capacity is there. Thermal capacity and latent heat is not there. So you just have to do this part. This part, no need, because thermal capacity is not part of the syllabus anymore. In the question, a hockey player strikes a disc uh, with the momentum is there. The disc gains the momentum of 3 at an angle of 45 to the original. Why multiply by 5? Because if you see the question, there was a hot water at its boiling point. So it was originally 100. And then when we poured into a copper container, the temperature is 95 for both. So it was originally 100 and now 95. So how much the temperature changes for the water? That is, the temperature change is 5. The mass is 0.3 and then 4,200. The hockey player strikes a disc with a hockey stick and the momentum is 3 at an angle of 45. State the magnitude of the impulse of the disc and in the direction in degree relative to the original direction. So this is related to resolution of a vector, like breaking down the vector. Only now the question related to two vectors which are angle of a 90 are there. So you don't have a question in which the angle is more than 90 or less than 90. So this is even a momentum is there, but that is the angle should be 90 when we want a result change. So again, I can solve this question, but as only 90 degrees now perpendicular vectors questions are there. Figure 6.1 shows a shallow tank viewed from above. A wave passes from one side and the direction of a wave changes. Explain why the direction of a wave changes as shown in the figure. So what will happen as a wave passes from one side to another? The density of a medium changes. So when the density of the medium changes, if there is a change in density, that causes a change in speed, and change in speed causes a change in direction. The next is the speed of the wave on the left is 0.39. Use information, determine the speed, determine the frequency. The wavelength is given to you like, look, this is a distance. This is a distance between a crest and a trough. And then this is the half of wavelength because the distance between the two successive crests is called one wavelength. But this is half of the wavelength. So half of the wavelength is 2.6. If this is 2.6, how much is this remaining? That's also 2.6. So the total distance will be equals to 5.2 centimeters. If the 5.2 is the total centimeter, how many in meter? So 0.052 meter. Because the distance from one crest to another, that is one wavelength. But this is a half wavelength is given. So one wavelength will be twice of this. So we got the wavelength and we know the speed as well. The speed of the wave is given 0.39 here. And the wavelength we calculated from the figure. So we just have to use a formula V equals F lambda. So we can work out the frequency. Is it clear, this one? Is it clear, this question? So the distance from one continuous line to another continuous line is one wavelength. So using this formula, you will work out the frequency. Which part? The next. Determine the speed of the wave on the right hand side. So how you determine? Look, after working out the frequency, we use the formula V is equals to F lambda. So F is equals to V over lambda. So V is a speed which is 0.39 and lambda is a wavelength 2.6 centimeter multiplied by 2 because it was half and then divided by 100 to convert into meter. So it was 0.052. So 0.39 divided by 0.052. Answer is 7.5. So frequency is 7.5 hertz. And we know the frequency does not change. If the frequency is 7.5 hertz in one medium, the other medium, the frequency will also be 7.5 hertz. The frequency never changes. So if you need the speed, how to get the speed? Speed is frequency times the wavelength. Frequency we already have like 7.5 it should be. But how to get the wavelength? So for a wavelength, you can use the concept of the ratio, like simple ratio you can use between the two parts. Like you can use, even it's not to scale, like you don't have to. So speed of the wave on the left-hand part was 0.39. Use information, determine the frequency. That we did. And the next part, determine the speed of the wave on the right-hand side of the tank. So we have the frequency and using the simple ratio, like example, this side to this side, like example, I will measure if this length is representing 5.2, how much this length is representing. So I can work out the wavelength of this. Or I can also use the angles. The angles are given, the angle of incidence is there, 45 an angle. So, but even it's not to scale, so I don't have to measure. I have the angles for in one medium is 45, another one is 33. The frequency like doesn't, so what we can use, the ratio of the speed and the refractive index or the ratio of the angle is same. So I can use like sine 45 over sine 33 is equals to speed in the first medium divided by speed in the second medium, or speed in the second medium, like speed in the first medium, and this is the speed in the second medium, because the ratio of the speed and the ratio of refractive index are opposite. If the speed is more, angle will be less. If the speed is less, angle will be higher. Like if there's a greater change in speed, so I can use this formula, like working using the ratio of the angles and the ratio of the speed. And that will give us the speed at which it will move in the second medium. Is it clear? The last part, how to work out the speed? Like you just have to use the angles, the ratio of the angle, like sine angles. So sine 45 is there. The final answer you have to calculate, like the ratio of the angle sine. There's a formula for refractive index. Refractive index is a speed in a medium, like speed of a light in air divided by speed of a light in medium. When the light travels from air to that medium. Okay. So actually, what is the concept here? The speed and the refractive index are opposite. So here, or the refractive index is sine angle I over sine angle R. So it will be sine 45 over sine 33 divided by the speed in the second medium, or speed in the first medium was 0.39. So we just use that, multiply, we'll get the value for V2. So sine 40, this is sine 45, sine 45 or sine 33, not 40 and 30, 45 and 33. And then multiply by the speed in the first medium, you'll get the speed in the second medium. So the remaining of the doubts which you have shared, I will discuss in next session. Where I got, because the angles are given 45 and 33. So the angle sine angle I over sine angle R. So we got 45 over 33 is equals to speed in the second medium divided by speed in the first medium. The ratio of the angle is inverse to the ratio of the speed. This is the angle in the first medium. So we just substitute. And what is V1? V1 is this, the first medium. So we just multiply, we got the value for V2. So remaining of the doubts I'll discuss next session.